Hello everyone, in this video we'll be solving problem 57, insert interval. The problem statement is we are given an array of non-overlapping intervals and we need to insert a new interval in it such that if the intervals are overlapping, we need to merge them. If not, then it should be placed at the correct index so that the output is still sorted. We need to return the intervals after the insertion is complete. In example number 1, we are given two intervals 1 and 3, and if we represent it in the x-axis, it would look something like this, where both of these reds are already given in the input statement, and we need to add this new interval in it, which starts from 2 and ends at 5. Because there is an overlap between the first and the new interval, we need to merge them together. After merging these two intervals together, the array should have 1, 5, which is the first array starting point and the interval's ending point, and the second interval will be 6 and 9 because it does not overlap with the new interval that we are trying to add. I hope you were able to understand the problem statement. Let's switch to whiteboard and discuss how we can solve it efficiently. When comparing two ranges, there are a total of 3 scenarios that could happen. The first one is where the new range that we are trying to add is after the current range, which means the ending index of the first interval is less than the starting index of the second one. So there is no overlap. So in the output, both of these will be marked as separate entries. Similarly, in the second scenario is where the new range that we are trying to add is before the current range that we already have in the input. This is similar to the first case because there is no overlap. In the output, we will have both of these added separately. And the third case is where we need to do some calculation. In here, there is some overlap between the first range and the second range. You can see the first range's endpoint is actually greater than the second range's starting point. In this case, the updated range should start from this point all the way until this end of the second range, which gives us a bigger range, but there's only going to be one in the output. And now we need to figure out how to calculate the starting point and the ending point of this interval. Simplest way to do that is to apply the math.min operation on the starting point of both of the interval that has some overlap. And to calculate the end of the interval, we'll apply the math.max operation on both of the interval's endpoints. Let's say we have this scenario where we have three ranges and all of them are overlapping with each other. As we are doing the comparison between two overlapping regions to begin with, we'll first compare these two ranges. Because there is an overlapping here, we'll take the math.min between these 2 points to calculate the new range's starting point and math.max on the endpoint. And once we have the first range identified, we'll apply the same operation and compare the new range with the third one. As there is an overlap, we'll repeat the same operation. With this solution, our time complexity is O of n, where n is the number of intervals given to us in the input statement, and the space complexity is O of n, as we are building the output with all of the non-overlapping intervals. I hope you were able to understand the explanation. Let me show you how we can implement this using C#. Here is my C# solution. I start by initializing my results variable, which will hold all of the intervals that needs to be returned. The first case is to cover all of the intervals that are before the new interval that we are trying to add, and there is no overlapping region between them. We are simply adding the intervals into the result array. Once this while loop is complete, we then go inside the second case where we manage the overlapping areas. And this is where we do the operation of math.min and math.max to calculate the new updated starting and the ending point of the range or interval. Once this while loop is complete, all of the overlapping intervals will be merged into a single interval, which is this new, and added into the result. The last but not the least is case number 3, where there are intervals in the input array which are after the new interval. So we are simply adding it to the results array and incrementing the pointer. This will run until we have iterated through all of the elements in the array. And once this while loop completes, we return the result as an output. This code, when submitted on LeetCode, beats 98% of the submissions in terms of runtime, and 61% in terms of memory. Thank you for watching this video. I hope you were able to understand the explanation. The details to access the source code is available in the description below. Feel free to check that out and I will see you in the next one. Thank you.